All right, so by definition, even though we talked about it a little bit yesterday, okay, is parallelogram is a quadrilateral. It's got to have four sides. And the only thing that makes it a parallelogram by definition is the opposite sides are parallel. That's why the rectangle falls in there. That's why the square falls in there. That's why the rhombus falls in there on that little Venn diagram thing that was up yesterday. Because squares have opposite sides that are parallel, so do rectangles, and so do rhombuses. Out of that little chart that we have with quadrilaterals, the only ones that don't fit this are the kites, because they don't have any sides that are parallel, and then trapezoids, which only have one pair of parallel sides. When parallelograms get written out, if I want you to know it's a parallelogram, if I do not give you sides that are marked parallel, I'll give you the little tilted box that's in front of the letters. All right. So now, with each one of these parallelograms, this applies to anything that is, this applies to anything that is classified as a parallelogram. So that means rectangles fall under all these properties, so do squares, so do rhombuses. Even though we're not doing the special ones today, we're doing those tomorrow, we're not going to add any additional properties until tomorrow. So everything that's up here now only applies to today, but it's also going to carry on to tomorrow. Okay, so there's 5 things to write out. I'm including the definition as one. So you don't have to necessarily rewrite the definition, but lines being parallel gives you specific properties, so I count it as one of the properties that are here. All right, so first one is that the opposite sides are parallel. Like I said, that's the definition. That allows you to have all this other stuff that's about to be up there, the other 4 things, allows them to exist for that specific quadrilateral. Okay, so again, you don't necessarily need to write it, but because the parallel sides give you properties, I count it on here. All right, second thing was, and again, we had this yesterday, but rehash it separate so you understand opposite sides are always going to be congruent. So again, that's true in any of them. Like squares, obviously, it's true because all the sides are congruent. Rectangles, we know the opposite sides are congruent. Same thing with the rhombus. Okay, so, but this also applies to anything that just has opposite sides being parallel. Next one is the opposite angles are congruent. Okay, so again, the ones that were directly opposite each other or the ones that have the diagonals connected to them, those angles are always going to be equal. Yeah. No. If you have to use this in a proof, you just literally write out, you can write out like property of a parallelogram, or actually write out like opposite sides of a parallelogram are congruent, not like any numerical or named postulate. Okay? All right, next thing is the diagonals bisect each other. Again, that's on that chart, but unless you're going to consistently look back at that chart, I would write this separate. And then the last thing is that, remember, those consecutive angles are supplementary. Okay, and that's just because you've got the same side interior angles there. Now look, since we got the parallel lines, if I start throwing diagonals and stuff in there, I can also have like alternate interior angles being congruent. That's going to come up. Where the diagonals cross, you still have vertical angles existing. So all this stuff that we've had in the past still applies, just because it hasn't been necessarily talked about in too long doesn't mean don't forget about it. On the one that's on the left, the one that's probably labeled number 5, I'm assuming.
Yes.
Yeah.
Okay. For this one here, all the stuff that's up there is dealing with angle measures. So that means only 2 things can happen. You can have opposite angles being congruent, or you can have the consecutive angles being supplementary. So that's it. If you're dealing with angles, that's the only 2 things you can really do. Unless you have diagonals, like I said, then you can throw alternate interior angles, but I really doubt you can see that. So what I would probably do, if I'm working with parallelograms, is figure out which ones are opposite angles, because those are always the ones you can set equal to each other. Meaning that I understand those 2 are opposite each other, and those 2 are opposite each other. So like right away, without doing any work, I can get a value for f just by recognizing that those are opposite angles, and remembering that the opposite angles have to be equal. All right, now obviously I know that these 2 have to be the same again because they're opposite angles, but I need a number value to actually, finish the problem. That's where the other part comes into play. So the consecutive angles, remember, are the two that are like on a same side as of each other. So either I can look at either these two together or these two. It doesn't matter because they're going to give me the same answer if I subtract the 82 from 180. Because, right, supplementary means that they're 180 when you add them together. Gosh. So do you want me to write an equation out with E or D? D. So I would say D plus 82 equals 180. That would be the actual work there. Now I understand. You probably didn't have to write that out, but because some of these problems are going to have equations in them with like x's and other variables, it's a good practice to do that. So if I subtract 82 from that, I should get 98. And again, since I've already said and established that those two were equal to each other, this also gives me the value for that one. All right, so now on the other one. Now if I go through like establishing all this stuff on side lengths. So over here, it's either going to be opposite sides being congruent, or it's going to be dealing with the diagonals bisecting each other. Like the whole fact that they're parallel just makes it a parallelogram, which again, like I said, in this case would be in the directions, even though they don't have parallel marks on the sides. So if I go through there and I look at my sides, I know that this side here and that one there are opposite of each other. You agree? You should, because it's right. All right, and then this one down here is opposite what number? So I know those two are equal. And then for the diagonals bisecting, remember when they bisect, that means that each one is being split in half. So like this one right here is being split in half. This one right here is also being split in half. So you got H is 9 and then G is 12. All right, so on 9, again, like until you get used to recognizing all the properties, I would suggest figuring out the fact that where these x's are, they're on segment lengths. So that means that you're either doing opposite sides being equal or you're doing the thing with the diagonals bisecting each other. It does. 2x plus 10 goes with this one. 3x goes with that. Otherwise, you can't do it. All right, so for the value for x, if I were to set up an equation, the 3x and the 2x plus 10 are both on the diagonal. Since this is a parallelogram, the diagonals are going to bisect each other, so I know that those two should be equal. You should be able to solve that equation, yeah? What do you get, x equals what? Yay. All right, and then for where the y's are, the two y's are on your sides. They end up being on opposite sides because otherwise you really wouldn't be able to do this. So these two sides have to be equal to each other. So I got 7y plus 1 equals 6y plus 10. So if I solve that out, you get what value for y? Strap on. All right, so first thing to point out on this problem is they have diagonals drawn in there. If the picture that I grabbed is associated with that, which I'm pretty sure it is, because I got it from the same spot. So you kind of have to imagine this without the diagonals in it. It's a little bit easier if you do that because the angles they're asking you about, like QRS is this entire angle. Okay, RSP is this entire angle. So those are the two I'm trying to find. I'm just putting different variables up there just so I can see exactly what I'm working with. Okay, now the other two they give you, SPQ is this one. PQR is that one. These two angles here, right, they're on the same side, so they're consecutive angles, which means, right, they add up to 180. They're supplementary. So the whole key to kind of doing this is I've got to figure out what the actual value for those two angles are. Because if I know what the value of this angle is, I know what the value of that one is, because they're opposite angles. Same thing here. If I know what this angle is, I'll know what that one is. Okay? All right, so if I take the two little expressions they give me. So this one is the angle SPQ, and if I add the PQR to it, again, I know it has to equal 180 because they're consecutive angles on a parallelogram. All right. So if I combine like terms here, what's 15 plus 11? Really? 15 plus 11? Is that hard? 20 what?
26.
Brilliant. What's the next step there? How do I solve it? Go. And then what? All right, what's 182 divided by 26? Go.
Number. Answer.
Answer? Perfect. What is that? 182 divided by 26? 7? 7. Okay, now, again, the whole idea of this, and I know I probably, because they had X up there, don't get it confused with over there. I was just marking where those other angles were. So the whole idea of having this is now I can use X equals 7 to get the actual values for the angles. Like SPQ, this one is 11x plus 2. This one over here is 15x minus 4. Plug 7 in. Meaning if I plug 7 in here, I'll get 11 times 7 plus 2. What's 11 times 7?
77.
Plus 2 is?
79.
So if this angle is 79, that means this one over here is also 79 because they're opposite angles. Okay? Now look, once I know that's 79,
I know what the other one is.
these two have to add up to how many degrees? So if I do 180 minus 79, that's going to give me the other one, which is? Boop, boop. Oh wait, did I draw it right? What's the smaller one? G. Yeah, I'm good. Okay. All right, so there's a few ways to go about this. I can either flat out use all the properties of parallelograms, find values, and I'm going to be fine. Or I can put something on each one of the angles, add them up, set them equal to 360. Either way, I'm going to have to plug a number back in. It's just the way you want to solve for x. It doesn't really matter. So I know that this angle right here exceeds this one by 46. Meaning that if I put an x here, what should I put here if it's 46 more than what this one is? Okay. Now again, if this is a parallelogram, which it is because that's what they tell me, if I put an x here, I can also put an x there. If I put x plus 46 there, I can also put it there because those have to be the exact same angles as each other. So now, I'm either going to add all those up, set it equal to 360 and solve for x, or I'm just going to take two of them that are right next to each other, which is probably what I'm going to do anyway, and set them equal to 180. Because here, as long as I find out what the value of x is, I know all the value angles that are up there. Okay, so if I solve this out, that's going to be 2x plus 46 equals 180. You did do that. That was part of it. Yes, that was part of it. Yeah. 180 minus 46 is 134. Yes. Okay. Then 134 divided by 2 is 67. What? I'm good? Okay. So that means that, look, as long as I know that, and I would have gotten the same answer if I added all of them together and set it equal to 360, all that would have happened is this would have been 4x and that would have been 92. So those are both 67, and then these two are whatever that is plus 46. What's 67 plus 46? Oh my God, I can't write a 3. Boom.